To enable life-of-field simulations, specific input data must be provided. This includes parameterizations for items or components used in unit operations, flow trajectories for wells and flow lines, fluid properties, and network incidences. Finally, the input must include references to run files for any reservoir models, as well as events which are used for well openings and setting of system targets and constraints. In order to perform unit operation calculations, parameterizations for the different items must be provided. These parameterizations are located centrally in a single file and are referred to by user-defined names. As an example, the parameterization for a pump includes a user-defined name, a maximum nominal power, and a scalar efficiency value. The pump description can be extended further to include a maximum pressure ratio, a minimum suction pressure and a maximum delivery pressure. With a known pump performance, tabulated data for how efficiency or delivered head varies with flow, and optionally rotational speed, can be included. With tabulated pump performance data, the maximum power and nominal efficiency are ignored. The branch file holds information about the flow trajectory for a given well or flow line. It further includes variations along the flow path for parameters like ambient temperature, diameter, roughness, and overall heat transfer coefficients. Optionally, it may include thermal parameterization descriptions for pipe walls. The branch file also includes definitions of locations for items and sensors for wells and flow lines. Any such item or sensor refer to the item specification file by the name of the parameterization to use. Multipliers for tuning or calibration purposes are contained in this file, as well as reference to files containing predefined fluid property data. Branch trajectory data can be entered manually or imported from files in predefined formats. Fluid data may be provided in two different formats. One option is the form of black oil parameters, where key data at surface and downhole conditions are provided. This includes densities, heat capacities, viscosities, and surface tensions. The second option is by Olga format property files, where required parameters are provided as functions of pressure and temperature. Olga format property tables can be exported from commercial PVT simulators like PVT Sim. The purpose of the network file is to describe how different wells and flow lines are connected in a production or service network. For each branch defined in the network, reference must be made to a branch file describing required data. When solving a network in a life-of-field simulation, the system needs to know which items or components it can use to achieve a solution. The fastest way to define which items to use for this purpose is simply to check the option, automatically use all active items in controllers. Optionally, each item to use can be defined to individual controllers. For more advanced applications, such items can be defined to controllers including PID parameters. The network file further includes settings for which pressure loss and hold-up models to use. In typical applications, a three-phase no-slip model will be used for wells, while a slip or combined slip and stratified model are used for flow lines. The network incidence defined can be changed during runtime through events rerouting wells and flow lines to destinations differing from the original one. The network file can also be used to set default fluid properties for the branches defined.